The unit that I have selected for my final portfolio lesson is derivatives, and the section that I have chose from that unit is 2.3, power and sum rules for derivatives. To find the derivative, we have to use the building block rules, and for my first example, I have f of x equals 19x to the power of 9 plus 14x to the power of 7 minus 2.4x plus 982. We have to first write this in an algebraic form, which would mean that we rewrite the first two parts as shown 19x to the power of 9 plus 14x to the power of 7. And we have to recall that when you multiply a coefficient by a variable with no exponent, that exponent would just be 1, which is itself. And for a number that is not attached to a variable, it would just be attached to x to the power of 0, because x to the power of 0, anything to the power of 0 equals 1, and that would make 982 by itself. And as we can see, this is how your equation should be, your function at that should be written. Like I said before, the rules of the derivative using the building block rules are to multiply the coefficient by the exponent and subtracting the exponent by 1. Like as you can see here, you multiply x by the exponent, which I have here as 9x, and then you subtract 1 from the exponent, which is 9 minus 1, and you have to remember to multiply that by the original coefficient. And for over here we have 14 times 7x to the power of 7 minus 1 using the same rules, and so on to negative 2.4 times x to the power of 1 minus 1. And like I said before, when there's a number with no variable attached, you attach x to the power of 0 to it, because anything to the power of 0 equals 1, which would keep it by itself, the number by itself. And if we calculate it, 19 times the exponent 9 would equal 171, and then by subtracting 1 from the exponent we'd get it 171 x to the power of 8 plus 14 times 7, which would be 98 x, and then 7 minus 1 as the exponent, which is equal to 6. And before, for 2.4x, we did 1 minus 1, which would just be 0, and it would take away the x, and the exponent would, and the derivative of that would just be negative 2.4. And since x to the power of 0 is 1, or I mean the derivative of a number without a variable attached will always be 0. For my second example, I have f of x equals 5 times the square root of x minus 4 divided by x to the power of 3 plus 3e to the power of x. And we have to recall that the square root of any number, or a square root of a variable such as x, would equal x to the power of 1/2, and that a fraction with an exponent at the denominator would just equal the numerator times the variable with the exponent being negative instead of positive. And the derivative of ex will always just be itself, or with the coefficient attached. The derivative of 3ex or 5ex or just ex by itself will always remain the same. So here we have it written in algebra form, which would be 5x to the power of 1/2 and subtracted by 4x to the power of -3 plus 3e to the power of x. And to find the derivative, we use the same rules by subtracting the numerator and the denominator that have a matching number in order to equal 1. Like as displayed here, we have 1/2 x to the power of 1/2 minus 2/2 because it equals 1. And we multiply by the exponent, which was 1/2. And for -4, we have it multiplied by -3x to the power of -3 minus 1, using the same rules. And then, like I said before, e of x, the derivative of e of x will always just be itself, along with the coefficient attached to it. And our final answer would look like 5f prime of x is 5/2x to the power of -1/2 minus 12x to the power of -4 plus 3e to the power of x. We have to multiply 1/2 with 5, which would be 5/2. And since we subtracted 2/2, which is 1, from 1/2, that would give us an exponent of -1/2. And we had originally -4, which we multiplied by 3, which would give us -12x, and it would give us an exponent of -4 by subtracting 1. Moving on, we have the equations of tangent lines, and this is the point slope equation that we use to solve for equations that are tangent to a certain line. For example, we have f of x equals 35 minus 3x squared at x equals 2. And now we already have x1, the value of x1 given to us at x equals 2. And we use this information to find y of 1. Y of 1 would equal f of x1, which is 2, and that would equal f of 2 in this equation. And then we plug that into our equation, which would be 35 minus 3 times 2 to the power of 2. And we have to do our exponents first, which would be 2 to the power of 2, which would be 4 times -3, which would be 12, and it would be 35 minus 12, which would give us a value of 23, which is our value for y1. Then, after that, we solve for m, which equals the derivative of f of x. And in this case, we would plug in 2. But first, we use the derivative of the equation. And remember, the derivative of a number that is not attached to a variable, like 35, would just be 0. And for this, we use the rule, we multiply the exponent by the coefficient, which would give us -6, and then 2 minus 1 would just be 1. So the derivative of this equation would just be -6x. Then we would plug in 2 for this derivative function, which would be -6 times 2, and that would give us -12 for m. And our overall equation would look like y minus 23 equals -12 times x minus 2. Finally, we have using derivatives in a business situation. And for example, we have the demand D for a product at price P dollars is given by D of P equals 300 minus 0.3 P cubed. Then it's asking us to find the marginal revenue when the price is $20. To solve for this equation, we must recall that revenue equals demand times price, and this would give us an equation of 300, as shown here, 300 minus 0.3 P cubed times P. And using the distribution method, we would get 300p minus 0.3p to the power 4. And once we've done that, we then look for the marginal revenue that it asks for when the price is $20. And we start off by first finding the derivative of the demand times price, which would be 300p, which would be 300 minus 1.2 p cubed. And now that we have our derivative function, we then plug in 20 for the marginal revenue, which would give us 300 minus 1.2 times 20 to the power of 3. And that would give us a marginal revenue of negative $9,300.